the Sustainability Management Master's Program, you are answering one simple question. Do you care about your future generation? If you care about your kids, their grandkids, then you care about sustainability. And a sustainability manager is someone who has the tools to make people understand how they can contribute towards developing a sustainable world. We have both part-time and full-time students. Our curriculum is 30 hours. Instead of thesis, we have a research project course and a seminar course which provides them with the kind of research background they will need to be successful in their job. But at the same time, sustainability is not always everything about environment. It also relates to the business. They will take a sustainable business strategies course. They will take a project management course. Most of these courses are going to be taught by industry people, the people who are doing sustainability on a daily basis as a part of their job. Any organization that has a large number of employees and has a physical infrastructure, they will have to have a sustainability office. If you have the passion to develop and maintain a sustainable world, come to us and we will help you shape your passion into a career which will create an impact. Everyone, today's seminar is sponsored by one of the joint sponsors of the seminar series, WSP USA. So Phil Jonat is a Vice President of Energy in WSP USA. He is a licensed mechanical engineer in the state of New Jersey. At WSP, Phil has had the opportunity to work on many different types of energy projects and systems, including energy efficiency, central plants, solar, offshore wind, utility scale battery systems, etc. So his current focus is on how to increase beneficial electrification of transportation and buildings while staying resilient to the effects of climate change. Phil, a Stevens alumnus. He graduated in 2008 with a degree in mechanical engineering after completing the co-op program. So you graduated in 5 years.
Correct.
Okay. So and today he is going to actually talk about sustainable energy system transitions. Welcome, Phil.
Thank you very much. So yeah, really, really appreciate you guys making the time for this, and definitely want to keep it a bit informal as much as possible. So happy to take questions even in the middle, but also wanted to tell a little bit of the story of my career, just because I think it plays into how the energy world's been transitioning and the decisions that you all will make as you finish your current program, whether that's the master's for most of you or whether there's anyone else calling in from undergraduate programs, et cetera. So very happy to be talking at a sustainability series. I think my obsessions has always been kind of making the world a better place and that environmental sustainability. So, what is sustainability? For me, it's always been about that creating a better life for everyone that we can, right? And how do we sustain life on this planet forever, right? As long as we can, and that really often at the corporate level kind of gets often called a triple bottom line. I've always kind of gravitated towards that environmental sustainability, but I've also seen plenty of situations throughout my career where either the financial sustainability wasn't there, right? You can't continually overpay for a green premium for something that's greener and cleaner, or you may see a situation with government debt or other situation that you say, well, that's not sustainable, right? It's the same meaning that we want these things, these institutions that we're building, these systems that we're building, we want them to last in perpetuity, right? Even though each individual mechanical equipment and power plants and transmission line, those will all at some point need to be replaced. The entire grid, right? The electric grid, the systems we built, we want them to last in perpetuity, right? And then finally, that social sustainability, right? Are we treating our workers well that are working on our projects, or are we just taking advantage of them, right? Or are women getting promotions in the workplace, or are they being relegated to second back seat on these things? So those are the main three areas of sustainability. And I've been interested in kind of all three of them at different times, and that's extremely broad. Now you see a lot of corporations talking about ESG, environmental sustainability and governance. Environmental, social, and governance. So similar to this, has similar themes. But for me, it kind of all started with that sustainability. And way back when I was an undergrad, in the early 2000s, I was already obsessing over this and thinking about what does this mean. And so the book Natural Capitalism was a really big influence on my life. I read this, I don't know, when I was, I think even entering my freshman year of Stevens. And this, the work that they did was kind of that broader picture of environmental sustainability first and foremost, but what else does that mean? So I'll continue with the story. Here's a picture of me, undergrad, with a fellow mechanical engineering graduate, Tom Moskal. And so I actually, again, I was already had read that book and was already thinking about sustainability and environmental issues. And I was an environmental engineer. Unfortunately, I had a co-op program, or maybe fortunately, but I had a co-op program that I just did not like the job. And I realized that environmental engineering was all about cleaning up other people's stuff, right? And again, that's a really noble job, and I'm really glad my company has tons of great environmental engineers on our team, but it just wasn't for me. I wanted to build the future, right? How do we look forward and build the clean green future? So I transitioned over to mechanical engineering as my major following that first job, and I moved started to move towards energy, and we're going to talk a lot about energy tonight. So I did do a stint in construction management and found that was also not for me. But again, I kind of have modeled my career since then on making sure that I stay close to construction and projects getting built and in the real world, because you can study and create, ideas about the future all you want, but if they're not getting built, right, then we're not actually changing the reality on the ground. And that reality is, climate change, it's carbon emissions, it's pollution, right? How do we fix those things? We need to build new things in order to get past that. So that's kind of, another job that I had as a co-op student. And then finally, I got into a consulting engineering role with a company that was doing HVAC and was building brand new buildings. And that for me was a really great role, and I loved it. And so I did go into the same field, although I pushed my way out of HVAC buildings work and towards, the wider world of energy that we'll keep talking about tonight. And so at some point I did worked with Stevens faculty and administration and helped create what we called at the time the green engineering minor. So it was a multidisciplinary minor program that lasted for a few years, and it was trying to take these ideas that we have about sustainability and say, well, how do we build that clean green future, and how do we make sure that our students are prepared for that? What do they need to know? So that was a really proud accomplishment from my Stevens career. And then at the time, environmentalism and all of the sustainability was growing in prominence in lots of different ways. So Stevens also invested in what's called the Center for Science Writings, and so John Horgan runs that center, and he created the Green Book Award at the time. So there was a few books that he selected that were the winning Green Book of the Year, and I got to talk to some of those authors on campus, and that continued to influence how I thought about the world. And so finally, I think when I was a senior, my fifth year, I went to a presentation that PSEG gave on campus, and that also really made me start thinking, I need to know a lot more about how the electric grid works and what is the like. I had only taken one or two electrical engineering classes. I had switched to mechanical engineering, and I never gave too much thought about it. But at that time, that's when I started to really realize that electricity was so important. So let's take a step back and talk about energy and what is energy. Energy is provided by these different sources here on this chart, and it creates the ability to do work, right? Back to those very simple first definitions. But we consume a ton of energy in this country and around the world, and it's all it's to heat and cool our houses and to do all these things. But these are the sources, at least in the U.S. And right now, we're spending a lot of time, trying to build these renewable sources, which have different characteristics, different performance than the old system that we have here, especially with coal, petroleum, and natural gas. And you can also think of these things as flows, right? You've got a system of coal that's flows of solid rock that are moving into the economy, getting burned, turned into useful work, turned into useful products, turned into other things, and then moving on. And petroleum's that liquid, and natural gas is a gas, obviously. And so you've got these different pipelines and ways of moving that energy where it needs to go. And then kind of at the highest level is that electricity. And nuclear tends to produce electricity directly. Renewable energies mostly produce electricity directly, not all of them, but you're producing that electric through that, and then you have to move those electrons through different mechanisms, right? You can't use a pipeline to move electrons; you have to use wires, right? And those systems are different. So I have here an unreadable chart, but this, if anybody doesn't know, this is called a Sankey diagram. It was produced by other lab for for I forget, one of the national labs commissioned this in 2017, 2018 timeframe. And this is the entire U.S. economy. The oil, petroleum, natural gas, coal, biomass, nuclear, all coming in on the left. And then as you go through each one of these, you've got losses, you've got different sectors where energy is used, then subsectors, and moving down till at the very end, it's things like individual refrigerators in houses, refrigerators that are in commercial buildings, et cetera. And so they've mapped the entire U.S. Energy flows. And so we'll kind of return to that a little later, but Sankey diagrams are really useful for thinking about energy. So why is energy so important, right? And it actually gets right back to these Maslow's hierarchy of needs. How do humans thrive, right? We need to have our physiological needs met. We need to be warm. We need to be safe, right? These kinds of things. And energy is critical to that, right? Especially as we see the climate change, right? The more energy you have, it's a form of resilience, right? If it's 120 degrees outside, plus, and the wet bulb is so hot, your body can't cool itself. You need air conditioning to survive, right? Same thing, we've worried about heating more than super hot temperatures in this country for so long. And same thing, those temperatures are lethal, right? And so we need energy to survive. So in addition, of course, food production takes a lot of energy. Sanitizing equipment or just food sanitation, right? That all takes energy. And we need energy to power our businesses, industrial processes. You can't develop without it. And so this is where I want to talk a little bit today, also about the I'm going to use the word third world. I hope nobody's offended by that. Sometimes underdeveloped countries, right? And so electricity, kind of going back to that electricity question, is one of the hardest things to provide for these emerging economies. And so you actually do have this, a U.S. fridge uses more energy on average than, many of the countries in Africa. And so, sorry about that. Supposed to close that. So this electric consumption is really critical to getting the people who live in these countries on a sustainable development path, right? Again, what is sustainability? It's not just creating the least environmental impact possible, but it's helping the most people too, right? We want to help the people in other countries to get the energy they need without making climate change worse and without affecting that. And so this is just one other chart that shows some of those same flows. And one of the interesting things is how much wood is used for energy consumption, and there's a lot of countries where people are collecting firewood to heat their houses and to heat their food, and that the transition of fossil fuels is actually quite sustainable for them, right? It's much better than the alternatives that they have currently. And so this shows some of the transitions that the U.S. has gone through over the years. Again, going back to that electricity question topic, electricity access has gotten a lot better over the past decade, but COVID actually did make things worse for people, and And so we'll see as the new numbers come out. Hopefully, we've gotten back on track to providing more electricity access to more people. And we'll continue. We'll come back to this conversation throughout the presentation. I did want to say thank you to Nat Bullard. He's got a really great slide deck online, and he did give me allow me to use these slides. So about half of the slides come from something that he had produced. So again, just thinking about energy growth, we need energy growth in order to create development, to create opportunities for people. But that's not quite the same in the rich world, right? In the OECD countries, we've actually been flat for many years, and I actually do expect that total energy use will go down in the United States and other OECD countries, and that's because electrification tends to reduce primary energy use, and that's because the primary energy use measures all the energy in, even when with natural gas we're burning it at a combined cycle plant, and 50% of it's wasted and 50% of it moves forward as electricity to provide to our houses and to our industrial processes. But as we electrify directly, electric processes tend to be much more efficient. Actually, the best example is the electric car that we talk about, and the wheel-to-well efficiency of an internal combustion engine car where you're putting gasoline in, you're really only getting about 15% of that energy as forward progress, right? But with electric, you put it in, your battery has some losses, your engine, your motors have a bit of losses, but you're really much closer to 75% efficient. So you get a huge efficiency gain, and so you'll actually probably see energy growth of energy really decrease in the OECD countries that already have all this infrastructure and are moving towards more sustainable options, whereas the developing world needs a lot more energy to lift people out of poverty, to get people that electric access that I was just mentioning on the last slide, and to move forward. So unfortunately, all that energy does produce tons and tons of carbon dioxide emissions, and they've been rising and rising, and we've not been able to really drop that yet. So you can see here at the very end of the chart that coal in black has started to dip, and that's really again driven by the OECD countries first, then the rich world, and then the third world is still building some coal plants and still using more coal right now, and it's often a domestic resource for a country like India, but the coal is starting to go down, and we really need it to go down fast in order to solve our climate change problems. But the others are still rising. So this is one of the challenges that you guys have, I'm sure, heard a lot about already, and we're going to keep talking about it now. So this is one. This is global CO2 emissions per person does seem to have gone down. So that is good news. But again, the global population keeps growing. So we need to get these things under control, and it's a long, slow process to fix this problem. And we'll keep talking about why that is throughout the presentation. So so at this point, continuing to talk about carbon dioxide and those emissions. This is a nice graph from Project Drawdown, which was another book that influenced me quite a lot. So I'm going to spend a few slides on what they taught me over the past 2 decades of thinking about climate change and sustainability. And so this is just, the sources of climate goes into the atmosphere, right? And then some of it also exits the atmosphere. So thinking about solving climate change, there's also the possibility that, besides just reducing these sources of CO2, that we also can support these sinks, and we can, increase the amount of CO2 that's captured by the natural world and by engineered processes as well, right? So thinking about this, I always think that this is the best way to think about climate change. So Drawdown Project, helped me when at a point in my career when I was really confused, right? Well, there's sustainability, there's energy issues, but is energy even the most important problem to solve, right? How do we solve climate change? Is it through, electric vehicles, or is it energy efficiency? Should we be investing in hydrogen? What about geoengineering? What about all these different things? And we all want to know that. And so Project Drawdown tried very successfully, in my view, to catalog all these different solutions that we know about, and then use some PhD students and others to then come up with this research to, is this enough to solve climate change? And what are the most important things we can be doing, right? And so again, probably read this book in 2018 or so. So this is only 5 years old, but it's really out of the a lot of people reading about climate change. It's just such a big problem. How do we really solve it? And this helped to answer some of those questions, right? And so they have solutions that are across all these different categories here of food, agriculture, buildings, transportation, everything. So their top 5 is actually not very strong in energy. So just so there are other ways to solve the climate change issue, but I've continued to invest my career, want to continue to encourage you all to join in the energy transition that we're in right now, because it's the most exciting area to work in. But there are other ways to work on climate change. So their top 5 includes work with forests, work with health and education and food, etc. Refrigerant management is very interesting. I'm not going to get into that too much today, but heating and cooling our buildings is using a lot of refrigerants, and these can be quite destructive, more than I knew. So the rest of their top 10 was dominated by the energy, wind, solar, etc. So that's again, over the years, I've kind of obsessed over everything within energy, right? I bounced around from working on energy efficiency and maybe smart buildings are going to make energy efficiency easier and better. And okay, what about cogen and working at bigger systems, right? Rather than working at small individual processes, and then getting into the renewable energy. So all these things are kind of where my career has taken me, and they're all exciting areas to work in. But over the last, what I kind of alluded to before is that electrifying everything is kind of my personal mantra. It's not technically true. We're probably going to need, one of these molecules at the bottom, right, to be a big system. I kind of indicated before, we actually have a solid system of coal, liquid system of petroleum, gaseous system right now. We'll probably still have at least a gas and a liquid system, whatever those are. They may be hydrogen, they may be ammonia, right, in the future. But electrifying everything is a good shorthand because of that efficiency gain that I mentioned before. And and there's so many processes that can be improved by electrifying everything. And that's kind of been, again, as I said, the mantra of the last couple of years that I've seen, and want to continue to push that until we see that it maybe outlives its usefulness at that point. So going back to Nat Bullard's presentation, he kind of talks about how we're going to decarbonize as 3 different, within energy mostly here, thinking about, the rise of renewable energy, which started out when I, started my career. I, was working in, this, I've actually been working at the same company, WSP, great firm. Been working there since 2008, under a company that was bought by WSP in 2014. But, we didn't have a big renewable energy platform in 2004, as this thing says, and didn't, even in 2008, it was very difficult to work in renewable energy for us as a firm. But we've really, hit our stride now. We're in the midst of, what I call now the energy transition. But the world is also moving towards this, how else do we get to net zero, right? So kind of moving in terms of, okay, originally it was we could just solve our problems if we could, invest in renewable energy. That has proven correct in that, the prices of renewable energy have come down. We've actually, a lot of the early climate change projections were based on, just using coal forever. And we see that, coal is really getting supplanted by renewable energy, mostly. And now we see, people calling this the energy transition, right? We're in the midst of taking these trillion-dollar systems that we have, whether it's the electric grid, whether it's the oil and gas pipelines we have, all this stuff. We need to transition it. It's going to take trillions of dollars of investment, and it's going to be messy, frankly, for a while. But we're going through this right now. And then finally, that net zero is really looking at the rest of the system, the harder to abate categories, places that can't electrify everything, right? Frankly, are going to be part of that harder area. And then there's also going to be those carbon sinks, those forests, the agriculture, the other things that I was talking about that Drawdown has mentioned to us. So onto the, this electrify everything. I kind of already touched on this, but, want to eliminate fossil fuels as quickly as we can. And that really not only on the climate change front, helping to solve that, but also improving air quality and improving human health. The United States, if people don't know, does actually have the cleanest air in the world. The Clean Air Act, which I learned about when I was an environmental engineer at Stevens. The Clean Air Act has done a great job, and you can look; it's done a much better job than Europe. European cities, and they have much worse air quality than we do here in the United States on the whole. But still, we keep finding that air pollution has more and more impacts on human health the more we look. So I just saw a study the other day that just idling cars right at toll booths has been shown to increase premature births, right? So women who are pregnant and they're too close to a toll booth where lots of cars are idling and trucks, right? They have premature births, lower birth weights, just things like that are impacting every human's ability to thrive. And then you look at again, European cities being dirtier, Chinese cities being even dirtier, and some of the worst air quality in the world in India and some of the other third world countries that don't have the same pollution controls. So we want to, by electrifying everything, we are looking to improve that human health throughout the entire world. Whether you're working in the United States or whether you're working abroad, there's huge benefits to this. And again, thinking about even at the area of gas stoves in your house, right? And if you have a super modern house, nice airy kitchen, a really good exhaust hood that you use, it's great. But a lot of people live in cramped, small kitchens, and you're burning, natural gas in your house in an area where you're eating and breathing and cooking, and that air pollution is actually not that great for us either. And again, we're continuing to learn more about this, and I do expect that we will continue to clamp down on fossil fuels just for these gains alone, not ignoring the climate change impacts as well. And so I already mentioned the huge efficiency gains, and Rewiring America is an organization that they helped to create this Sankey diagram that I already showed you, and then the author of this Sankey diagram, he formed this organization, Rewiring America, that's really dedicated to getting those efficiency gains for all Americans. So their program is actually mostly focused on kind of that residential more than the industrial, right? But it's thinking about all the fossil fuels that are used in an ordinary home, right? It's that gas stove, it's that heating system for winter, it's the car with gasoline or diesel, it's the dryers, water heaters, right? It's really kind of 5 machines, but multiplied out by hundreds of millions of homes and buildings, right? How do we turn over that fleet of machines and get those efficiency gains, get those benefits to everybody? And they show that there really is quite a bit of value to unlock for everybody. So I've been really inspired by Rewiring America's mission as well. So going kind of back to the beginning of this presentation of, okay, well, where are we using energy and how? I kind of mentioned that 20% is non-fossil fuels. It's that electricity, right? And then the rest of it is is still fossil fuels. And so we've got a long way to go towards electrifying everything. It actually, electricity, because this is on a time scale here, electricity kind of came up and grew to that 20% of the energy we use in this country. And it kind of has stagnated from there. So this electrify everything movement seeks to continue to improve everybody's access to electricity for everything. An electric car, as I said, thinking about all those appliances in the house being electric, but then, you know, electrifying industrial processes too, right? And electrifying, you know, big boilers and steam processes with heat pumps. All these technologies have improved so much. So I have this slide just saying, well, how do we do it? And I kind of just put a few categories, right? I get some of you are different types of engineers, but you know, electrical engineering is clearly one of the keys, right? If I could go back to school, I'd go back and, you know, become an electrical engineer. But we've got so much work to do on building the electric system, more transmission lines, more interconnection queues, which are how we get new power plants onto the grid. But we also need to decrease the cost of electricity. If you look, you know, we're here in the Northeast, prices tend to be higher. California, prices are very high for electric, right? We do need to keep the cost of electricity low and even decrease it over time if we can, because it's so important to that well-being. And again, it's even more important overseas. So it's always kind of been the case that, you know, because a lot of the price of electric is based on the price of natural gas. You get natural gas in, you get between 30 and 50% efficiency, depending on whether it's a peaker plant or a combined cycle plant. And then then the price of electric is now 2 to 3 times the price of, you know, maybe even 4 times the price of natural gas, right? And so we need to decrease that cost of electricity. And that's partly by, you know, new renewable energy systems, new ways of building wires, more competition on the grid. These are all, you know, things we need to do. We also need to shift loads around, right? So there's a saying that it used to be that, you know, the use of energy, the use of electricity was very variable, right? People turn on their lights throughout the day, and that was a huge variability. And then we ramped power plants. That was scheduled, right? Now we're moving to a world with renewable energy where, you know, the wind doesn't always blow and the sun doesn't always shine, and so the electricity can't be scheduled as much as it was before. It's not as dispatchable, but we can actually make the loads more dispatchable. So, you know, people like Google and Microsoft are, you know, figuring out how to make their data centers more dispatchable at a grand scale. But there's also, you know, just again, going back to residential, you can shift, you know, when do you heat your hot water using electric hot water heater, right? You got a big tank full of hot water. It doesn't need to fill up the second you finish your shower. It just needs to be ready for the next shower, right? When's that going to be? When do you need that energy by? So shifting loads is one of those important things. And then thinking about resilience and microgrids, that's really important, right? Again, in a climate change, in a changing climate world, changing temperatures, changing, you know, natural forces, we need to be more resilient. And everybody already knows about power outages, but if we don't get our grid to be more effective, you know, and the first time somebody, you know, they electrify their whole house and they end up, you know, freezing in the dark, right, on a cold winter day, that's going to be a problem. I know when I put in heat pumps for my house, I was pretty scared of that my wife would be very upset with me, you know, on a cold winter day if that happened. So luckily, I live in Jersey City and the power is quite reliable here. But I lived through Hurricane Sandy in, you know, Hoboken and Jersey City, and there's major power outages here too. And so we need to make the grid more resilient. Mechanical engineers, right? We have a huge role to play here. And, you know, tops of my list is heat pumps, right? So important that heat pumps is just a magical technology. And we've known about them not forever, but, you know, all the air conditioning and refrigerators in everybody's house are, those are heat pumps, right? They're just in cooling mode. And a heat pump can heat and cool. And we're seeing just leaps and bounds improvement in the technology. Heat pumps are working at colder and colder temperatures for, you know, for people who are reliant on, you know, getting heat out of the air in winter. But then also seeing a lot of heat pumps that can now produce steam, right, for industrial processes, so that we can electrify steam without burning gas or oil. And then there's also, direct air capture from the air, carbon dioxide, CO2 usage in new processes, sequestering underground, right? These are all great roles for mechanical engineers throughout. And then batteries are another one of those key technologies, and chemical engineers are kind of at the top of my list for that, right? That their battery chemistry is changing so rapidly right now, and battery chemistry is critical to making electric vehicles and all sorts of other processes work. Electricity is the biggest commodity in the world that has no major storage opportunities. There's a few ways to store electricity in some pumped storage plants, but batteries have gotten so much better. When I first started thinking about this, this is roughly right around, I'm thinking about like right after I graduated, and I kind of saw people starting to invest in EVs and hydrogen cars, hydrogen fuel cell cars, and biofuels, ethanol, right, as well as others. And I didn't know which one was going to win, right? How can I predict the future, right? But batteries got so good so fast, and I didn't think that was going to happen because batteries have been around for 100 years. And I was like, I thought they'd be too heavy, and now we're seeing batteries that possibly can power electric aircraft. They're so light, right? And we're seeing just so much innovation there. So really have high hopes for that. And really, no matter, even if you're not an engineer, there's so many different roles to play in the movement to electrify nearly everything, right? But these are some of the top ones that I thought of for everybody here on the presentation. So a little bit here about EVs, just in case you're not following. This is global sales, but they've grown incredibly fast, and we're kind of on what they call it S curve adoption, right? We're starting to enter that exponential growth, and so EVs have been really successful. They've pushed out all the hydrogen cars are not really cutting it right now, right? There's only, I don't know, a handful in the U.S., about 10,000. But we actually we're now reaching the monthly sales that 2024 will be, a year of more than 1 million electric cars sold in the U.S. And again, globally, they're moving much faster in Norway, and the rest of Europe as well as China are moving incredibly fast on electric vehicles. And again, moving back to this, how are developing world, how are they going to compete, and how are they going to transition? Seeing a ton of innovation in two-wheeled, electric bikes, electric motorcycles, electric three-wheeled deliveries. This is a really exciting area for on the EV front as well, and all enabled by these cheaper, low-cost batteries. So again, going back to how Bloomberg New Energy Finance is thinking about this is, we're going to need more energy. We're across the world. We're not going to use less energy, except in the rich countries where we have this interesting dynamic of primary energy moving directly to electrification. But the rest of the world is going to need a ton more energy. We're going to have, a lot more electric demand throughout the world, a lot more power generation, and the grid's going to spend tons of money on this. In addition, hydrogen right now is kind of the molecule of the future for our gaseous supply of energy. So we're going to see that grow as well. So again, I think a lot of people tend to be overly negative about how the world is evolving, but the U.S., I affectionately call these the Uncle Bills. And so they've been a lot of legislation passed really since, these are all since Biden got in office. And so the first one was called the Bipartisan Infrastructure Law, or Uncle Bill. And so this was mostly grants. And the way I'm thinking about this is on the energy front is that this was passed, by Republicans and Democrats. And they said, we want to provide these grants to a whole bunch of new technologies, a whole bunch of different options that are out there. And each one's a bet. that we can, scale up from there. That if we provide these grants, that people are going to then, be able to prove out their technology and move forward. Then the CHIPS Act is more focused on security of supply for especially semiconductor fab plants and computer chips and things like that. But there's also a bunch of money for basic science, advanced manufacturing that's going to advance clean energy as well. And then finally, the big one, Uncle IRA, also known as the Inflation Reduction Act, IRA, that is mostly tax credit subsidies. So these are subsidies for people who are doing projects. So for example, any clean energy technology, including nuclear, including renewable energies, if you build it, you basically get 30% off but it's in the form of a tax credit, right? And these tax credits have been very successful over the past decade plus of helping wind and solar to scale up. And now it's available to more technologies like geothermal and nuclear and these others. And so this is really the one it's not so much on the grant front. It's not giving away money. It's just taking 30% off of the total cost of production or investment in building these things. And so the government's purposely, less tax revenue coming in order to subsidize clean energy. And so this is a huge bill. It was estimated at roughly $400 billion over 10 years, significantly bigger than the other two as far as the clean energy. And this is really it's really changing the manufacturing base in the U.S. because there was quite a bit also not just renewable energy projects, but also incentives to build photovoltaic new factories here in the U.S., build new EV car manufacturing in the U.S. And so this is just an enormous investment, and so we're really going to see that bear fruit in the next couple of years. So this is again from my friend Nat here saying, the first $1 trillion invested is the hardest. And one thing I think a lot of people don't understand, engineers don't understand, is just how big the scale of the energy industry is, right? I've already mentioned you've got coal is a huge industry, even though it's dying in the US. It's still a huge industry. You've got petroleum industry, which is just absolutely enormous, one of the biggest industries in the entire world. And so we finally hit $1 trillion of investment in 2022, right? And 2023 is going to, blow this out of the water. But frankly, as I was starting my career, there was a lot less money flowing into these renewable energy projects, these other things. And so the energy sector does tend to be kind of private sector led, right? A lot of this money is going to be spent either on clean or dirty, right? People need energy. We have processes for building new energy plants, right? And it's either going to get built clean or it's going to get built dirty. And that's what the government putting their thumb on the scale, saying, okay, 30% off of your taxes is quite significant, and it's going to drive more investment in that direction. But this is great to see that we've hit this marker, and this does include things like EV battery plants, right? This is where the car business is a huge business. Trillions of dollars every year spent around the globe on that business. And so again, no matter what you're interested in your career right now, energy transition is going to impact that, right? It's not just sustainability, but the world of energy is going to impact, whatever you're doing with your career. And so this is just, again, the suggestion from Bloomberg New Energy Finance is that between 2022 and 2050, $194 trillion is going to be invested. And so you can see EVs sucking up a lot of that. But here's some of the other categories, right? These are the low carbon power sources, right? These are the power plants. This is kind of more where I'm working right now, mostly. But then the grids themselves, right? This is the electrical engineers that we were talking about. They need big investments. Carbon capture, I mentioned that as mechanical engineers really being involved there. Heat pumps, same thing with mechanical engineers. And then we're still going to need investments in fossil fuels, right? we can't turn off fossil fuels tomorrow because otherwise we'll all be in the dark. And we do need continued investment in fossil fuels in lots of ways, right? But we need to bring the oil companies and the others along with us. So I'm happy, to be, working with a few of those fossil fuel companies, a few of the mining companies and others that are using tons of fossil fuels right now and helping them to electrify as well. So this is key. So again, as you're starting your career, this is going to impact you no matter what you get into, right? You want to be in the fashion industry and sustainability for fashion or clothing, right? You're still going to see that energy transition affecting you in some way, right? There's going to be new materials. There's going to be other things. So I'm very excited about this, as you guys can all tell. It's extremely exciting. I wanted to have one last slide about what happens in the third world countries and the non-OECD nations. And really, I think it's all about leapfrogging, right? The term leapfrog is talking about and thinking about how if you have not already made $1 trillion investment in your electric grid, how can you build your grid differently, right? And the biggest and the easiest example for people to see is that in the United States, we developed the technology of phones. And you know what we did? We spent billions. I don't know if we spent trillions, but we spent billions of dollars, and every single house and every single business and everything got a copper landline to that location, right? We spent all that money on that. And a whole bunch of countries never got, they all had phones of some sort, but they didn't truly get a phone in everybody's hands in the entire rural populations of these poorer countries. But now cell phones have kind of penetrated to that level, right? Nearly everybody has one, or at least has access to a cell phone, right? And so we want to see that same thing, that same leapfrog. We don't need to build the coal systems. We don't need to build the oil pipelines, the natural gas pipelines, if we can move to the clean green future. And so how do we do that, right? And that these countries have that opportunity to leapfrog. And so it's not going to be easy, right? There's a lot of technical challenges that need to be solved. So I hope some of you will be spending your careers working on these issues in third world countries. I'm very excited by it. I don't do a lot of work, my day job, around this, but it's really how we make the world a better place for lots of people who need more energy to make their lives better. They need more energy to develop industries, self-sustaining industries, clean industries, right? That can power their economic growth. And so I do see that distributed solar and batteries, right? This is so easy now. Everybody can get a solar panel on their backpack, on their RV, if you're in America, or on your house in Nigeria, in any country, right? And batteries have come down in price, so now we're seeing their ability to utilize those batteries more effectively, cheaper, better performance, so that they can study at night. There's a lot of people who still on that list of from the beginning of this presentation who don't have lighting at night, right? You can't study, you can't go to school at night with that. And so you want to, that's going to really support kind of that residential, that lower level. The real question that remains is, can solar plus batteries power industries, and can they power actual economic development? And I think that's still to be proven. And I challenge you, if you're interested in working in this area, to prove that this either is going to work, or if it's not, then what is needed, right? Is it large scale hydro or nuclear, or what is going to be the clean technology that can support the developed countries moving forward? And there's a lot of great signs on this. So I'll give you two examples from Africa. One is that Kenya is a world leader in geothermal energy. They have great geothermal reserves there. And so I do expect to see an Eastern African grid that's kind of based off of geothermal as their hub, as opposed to solar, right, being the biggest power source there. And so I'd love to see Kenya, continuing to grow their electric base and to industrialize based off of clean power, and hopefully it's low cost as well. And so this last bullet is really about Nigeria, but it also harkens back to the beginning of the presentation and the Center for Science Writings. I wrote an essay that year for the Center of Science Writings, again, 2008, that was about eliminating subsidies. And so I don't have a picture of it. I saw one the other day, and I couldn't find it for today. But in Nigeria, they eliminated subsidies for diesel, and Nigeria is a big oil producer already. But frankly, should they have been subsidizing diesel production? Right? It has all these negatives. That air pollution we talked about, climate change. Frankly, Nigeria could sell it on the market abroad and earn a lot more money. And would that money do better for people coming in that way, or would it do worse? Right? These are very complicated development questions. But about a year ago, Nigeria eliminated these subsidies and kind of cut off cold turkey. And cold turkey is very hard, right? I'm sure there was a big backlash. I'm sure there was problems associated with this. But what you've seen since then is the solar market in Nigeria take off like a rocket, right? And so all these people who had residential diesel generators, because they had an unreliable grid, they had backup diesel generator for themselves. They're now all moving to that solar plus battery. So I thought that was a great story, and we're seeing a lot more of that. So I'm going to close here. These are just some other resources for you, other things that have inspired me over the years in the different categories around here. And so I heard a bunch of pings, so I believe those are all questions. Happy to take questions now, and really appreciate your time.
All right. That was an excellent presentation. I think there is some feedback. Thanks, Phil. I'm sure that there will be